In this video, we're going to talk about how to work this problem from Newton on function transformations. So it says the graph of y equals f of x is shown below the dashed curve. Manipulate the green draggable points to obtain the graph of y equals f of the opposite of x plus 3 minus 4, the solid curve. Okay, so what we have to do first is analyze this expression that we have here, the transformed graph. And so on this problem, what you want to do is when you analyze this is to take a look at this number in here. So on this particular one, because of this plus 3 in here, what we're going to need to do is to factor out this negative, and we'll have to factor it out of both of these things right here. So if I factor in this negative 1 out of x and out of this 3, then I am going to get this expression right here. And you can see if I distribute that negative sign through the parentheses, I will get exactly what I have up here. Negative times 1x, right, will give me the opposite of x, and negative 1 times negative 3 will give me a positive 3 right here. And so you might ask, well, why do you have to do that? And the reason is because, and that's a tricky part, but the reason is we need to use these function transformations, right? These are the things that they talk about. And so all of the operations that we do in this particular section are on this list right here. So these are basically the allowable things that we can do. We can add a number k to a function. In here in this table, k will represent a positive number. And the effect that that has, it shifts the graph of f of x vertically k units. Over here in this column, I have the pointwise effect. So what that would do is for each point on the graph, it would add k to each y value, and so on and so forth. So the reason I factored out that negative sign was so that I could easily figure out, or not, maybe not so easily, but it's going to help me figure out what transformations to apply here, because it has to be one of these. And in this particular problem, I have a bunch of transformations that are being applied. The order in which you apply those transformations is going to matter here, okay? So what I'm going to do is to look at this and try to figure out which ones to apply. So I'm going to start with y equals f of x. That's that dashed graph in the original Newton problem there. And so what I'm going to do is start applying these transformations right here, and starting with y equals f of x to try and wind up with this graph right here, okay? And the order in which you do those things is important. Sometimes you can change the order a little bit, other times you cannot do that, and so that's one of the tricky things about these problems. Alright, so starting with y equals f of x, the first thing I am going to do is to replace x by the opposite of x. So that's this very last one down here. And that will at least get me this negative sign in the parentheses there. Alright, so I'm going to replace x by minus x. The effect that I'll have symbol-wise is that I'll have now y equals minus x. And then what I'll have to do with those two green points in there is go to change each of the x values to its opposite. And so we'll get to that later. Alright, so I'm a little closer to this right here, but I still have a long ways to go. So looking at the other operations, the ones that I'm going to do next is this one right here. I'm going to replace the x by x minus 3. And when you do that, you'll need to keep that x minus 3 in parentheses like this, okay? Because that minus sign will apply to all of these things. So the problems where you have two terms in here and the negatives, you have a negative sign or a number, are fairly tricky. Okay. All right, the pointwise effect that will have to those two green points is that I will need to add 3 to each x value inside there. All right, and so you can see I'm a little bit closer to this, having this entire formula right here. The only thing I'm missing is that -4. So I look and see which one does that look like, and you can see it looks like this one right here. So I am going to subtract 4 from f of x, and that will give me exactly what I need. This and this are exact matches, okay? And so what I did was, starting with y equals f of x, I figured out how to apply these transformations, right, so that I would wind up with the graph that they show me in the question problem, okay? Okay, and so now each of those things have a corresponding pointwise effect on the graph. And we'll look at what each of those are. For instance, that last one, if I subtract a positive real number from the function, then that is going, I will need to subtract 4 from each y value in there. Okay? All right, so now going back to the original problem, it looks like this. I'll need to put this so we can see both of those things. All right, and so when I do these problems, for some reason, I kind of wish that they went ahead and just lined them up like this to start with, because I like to have them lined up like this when I start, okay? I guess if they just showed this, then it might be, you might not be able to see the dashed graph. But once I figure out what transformations I applied, then I'll start moving the points around. I'll go and line up those points like this. Okay, and then going back to my list, the first thing I need to do is change each x value to its opposite. So that's the first transformation that we did. So here you can click on the point, and you can see that the x value here is 0. The opposite of 0 is 0, so that point kind of stays where it's at. Clicking on this point, I can see that this point has an x value of 3. Right? And so I would change that to be a -3. So I would drag that over here and make it a -3, like that. Right? And this point stayed put, which is good. Otherwise, I would have had to drag it back to where it was. And sometimes you'll have to do that on these problems. All right, next up, right, we had this transformation. And so the pointwise effect that it had was it added 3 to each x value. So what I would do is go to each point that I have right here and add 3. So this point was at 0, 0. So I would add 3, and that would mean that that point would move over to 3, 0. When I do that, you can see it dragged this point 3 units over as well. So with that horizontal shift, I didn't have to go and do that separately. So that's good. Okay, next up. Subtract 4 from each y value. Okay, so I would go to this point right here. It has 0 as a y value, so I would go down 4 units. 1, 2, 3, 4. Again, we see that this the other point was dragged down 4 units also, so that's exactly where it would have to be. Okay. All right, and so I've gone through my lists and everything. And so when I click submit, that should be good. All right, and that's it on this particular one.